The method of elimination is a quick strategy to solve systems of equations in two variables. Elimination works when substitution is difficult to come about because it may be difficult to isolate a variable, or elimination is used when you have been asked to use the method of elimination. Okay, so sometimes they will ask questions within the steps of using the method of elimination, and in that way you cannot avoid the method of elimination. So let us use the method of elimination to solve this system of equations. So the first thing is to label the equation so that we can, let's call this equation A and equation B, okay? So that we're just giving them names so that we can refer to them by their names. Okay, so looking at equation A, the elimination method, the first step for the elimination method requires you to compare the coefficients to find additive inverses or the same coefficient. So, okay, so step one, the point of the elimination method is to subtract the equations to make one variable to be eliminated. So for a variable to be eliminated, when we subtract, that variable should become 0. Or when we add, that variable should become 0. That said, we're looking for the same coefficient or inverses. Okay, so let's start by observing equation A. The coefficient of x in equation A, the coefficient is the number that multiplies the variable. So the coefficient of x in equation A is 2. The coefficient of x in equation B is 5. They are not the same number. They are not inverses. Inverses means if this one is 2, this one should be -2, so that when we do 2 plus -2, we get 0. Okay? So the coefficients are different. We go to the next variable. We knock on the door of the variable y. The coefficient here is 1. There is a hidden 1 right here. So when you just see y is the same as 1y. So the coefficient here is 1. So 1, and then the coefficient here is -3. Okay, when there is a negative sign in front of a coefficient, that coefficient takes that negative sign. Okay, so the coefficient here is -3. So that said, we have 1 and then we have -3. Those are not numbers that we can subtract to get 0 or add to get 0. Now it is the time to do the job of making the coefficient of a variable either the same or additive inverses. Okay, we can do that for both of these variables. For example, if we want to make the coefficient of x in both equations A and B the same, we will multiply the first equation by 5 and we multiply equation B by 2. Okay, it's the same as finding a common denominator. Just say 5 times 2 is 10. So there is a way to make this 2 become 10, and there is a way to make this 5 become 10. But maybe 10 is a very big number to work with. I will come to the equation y. I can make this one a 3, a positive 3, so that if I add it to this -3, I get a 0. So I will multiply equation A by 3, okay? So let me get we get a new equation. We get a new equation. So I will go 3 times equation A will give a new equation that says, so we're multiplying every term in equation A by 3. So 3 times 2, so I will have 3 times 2x plus 3 times y equals 3 times 5. Okay, that is what I'm doing to equation A. Okay, the goal is to make this a 3 so that I can add to equation B to eliminate the y term. So my equation A becomes 6x plus 3y equals 15. Okay, so that is my new equation A. Now I will rewrite my equation B below it. So my equation B remains the same. I'm not doing anything to it. 5x minus 3y equals 7. I did multiply equation A by 3 so that I will have additive inverses on this coefficient here. Now, when I have those additive inverses, this is the time to add the equations. So now I will add these two equations. Okay, when we add, we only add corresponding variables. Okay, we only add variables that are like variables. So 6x plus 5x. Now I'm adding the two equations. I have 6x plus 5x is 11x. Now 3 plus negative 3 is 0. Okay, so I don't worry about it, just leave that blank. Jump to equal to, now I have 15 plus 7 is 22. All right, and so now I divide by 11 on each side, and that will give x equals 2. Once you get the first value for any variable, you may go ahead and use substitution to get the second variable. All right, now I know that x equals 2. I will substitute that value for x in any of the equation. Okay, so substitute x equals 2 in the old equation A, in the original equation A. Okay, so that equation A says 2x plus y equals 5. Now I know the value for x, it is 2, so I go 2. Instead of writing x, I replace it with 2, and then I go plus y equals 5. All right, continue on the right side here. Okay, so I have 2 times 2 is 4, so I have now 4 plus y equals 5, and I will subtract 4 from each side. 4 minus 4 is 0. Okay, so we can cross that out, and y comes down equals 5 minus 4 is 1. Okay, and so y equals 1 and x equals 2. So we found the solution. The solution, or the true values that will make these two equations simultaneously true, the values will be x equals 2 and y equals 1. Okay, does this remind you of ordered pairs on a coordinate plane? Yeah, that is what it is. So you could also solve systems of equations by method of graphing, and when you graph, the solution will be where the two graphs intersect. Okay, so you can use Desmos graphing calculator to type in the equations, and Desmos will graph it for you, and you just go and look for the point of intersection. If you do that on Desmos, then the point of intersection will align, will tie with this solution. The point of intersection will be at x equals 2 and y equals 1. This will be the coordinates of the point of intersection, which is also called the solution.